everyone. Today we are going to determine the values of sine, cosine, and tangent given some values of a triangle. Okay, so in this section then, we need to remember the formula for sine, cosine, and tangent. So I placed in one of the videos that we had in the previous section, we used the acronym SOH CAH TOA. So that's SOH CAH and TOA. So this represents the formula for sine, cosine, and tangent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Again, there is another video on how to use the SOH CAH TOA in order to find for the missing side of a triangle. I will put the link of that video in the description box below. Okay, so let's go over the problem here. So we're going to use this in order to solve the parts of this triangle over here. So in this problem that we have, we are given that sine theta. Theta is it's an x for an angle. So we don't know what the angle this is, so we represent it as theta instead of x. That's because again theta for math is represents an angle. So in this equation that we have here, sine theta equals 20 over 29. If we say sine, it means so, opposite over hypotenuse. That means this is our opposite and this is our hypotenuse because sine is so. Now let's label the parts here. So going to the parts here, this side right here will be the opposite. So this is the opposite side. This side right here of the triangle would be the adjacent. And this side of the triangle right here is the hypotenuse. Now, if you forgot how to label the triangle, how do we determine which one's the opposite, which one's adjacent, which one's the hypotenuse? There's another video on that. I will put the link of that video in the description box below. Okay, so going back to this, we have opposite is 20. That means from here, opposite to that, the length of this side of the triangle is 20. And then the hypotenuse is this side of the triangle right here is 29. Since we're looking for cosine theta, cosine means CAH, adjacent over hypotenuse. We don't know what the adjacent is. Although we have the hypotenuse right here, but we don't know what's the adjacent. So then we are going to solve for the adjacent since this is a right triangle and we are given two sides and the angle is missing. So that means we are supposed to use the Pythagorean Theorem. So again, there's another video that talks about how to use the Pythagorean Theorem to solve missing side length of the triangle. Again, I will put the link of that video in the description box below. So the formula for Pythagorean Theorem is leg squared plus leg squared equals hypotenuse squared, or in other textbook they use a squared plus b squared equals c squared. So the a and b are the two legs. So then let's just represent this as x because we don't know what this is. So then we can go ahead and say that is x squared plus the other one is 20 squared equals 29 squared. So then if we use the math here, so this is x squared plus 20 squared is 400, and then 29 squared is 841. So 841. So then we want the x by itself, so we subtract 400 from both sides, minus 400 here. So then we are left with x squared is equal to 441. We want the x, so then we square root both sides, so cross out the square and the squared and the square root. So then our x here is 21. So the length for this is 21. So then from here, we can already determine our cosine theta. So again, the formula for cosine is adjacent over hypotenuse. So then I can go ahead and say my cosine theta is equal to adjacent 21 over hypotenuse 29. So this is the value for cosine theta. Now let's move on to finding for tangent theta. So tangent theta is TOA, opposite 20. So that's 20 over adjacent 21. So then this is the value for tangent theta for this triangle. At this time, I would encourage you to pause this video and try this problem out on your own. Find sine theta, tangent theta, and if you're done, unpause it and check your answer. Okay, we go over the problem here. So first, we label the parts. This is our theta over here in this corner. So this side right here would be our opposite. This is our hypotenuse that is across from the 90. And this is our adjacent. So that's our adjacent side. Now, looking at the given right here, cosine theta. Remember, I'm going to write the formula over here. SOH CAH TOA. So again, there's another video for that. So since we have a cosine, so that means it's CAH adjacent over hypotenuse. So that means this 8 is our adjacent and this 17 is our hypotenuse. So from here, we can label this as 8 and the hypotenuse is 17. So we are missing this side right here. Again, to solve for that missing side, we can use the Pythagorean Theorem since this is a right triangle and the angle is not given. So that is a squared plus b squared equals c squared. So these are the two legs. So I'm just going to go ahead and write, let's just name this as x. So that means that's 8 squared plus x squared equals, the hypotenuse is 17 squared. So 8 squared is 64. Plus x squared is equal to 17 squared is 289. So then we want the x by itself, so we subtract 64 from both sides, minus 64, so that we can cross the 64 out. We are left with x squared is equal to 225. We want the x by itself, so we square root both sides. So then we are left with x is equal to 15. So our x right here, or the missing part, is 15. And then from here, we can get the value for the parts. So we have sine theta is equal to, so opposite is 15 over the hypotenuse is 17. So that's 15 over 17 is sine theta. Now let's have the other one here, tangent theta. So we have tangent is TOA, opposite 15 over 8, which is the adjacent. Did you get the same answers as this? Good, perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!